We're going to go ahead and do a review of different forms of variation before discussing our new types of variation that we're learning about, joint and combination. So with indirect and direct variation, we know that with indirect variation, the formula we use is y is equal to k divided by x. Okay, and we know if we have y equals k divided by x, our k, constant of variation, is equal to yx. And what that means is for every point in our data set, when we are looking at indirect variation, the product of y and x is the same value. It's a constant. So if I look at this table here, I have 1 times 16 is 16. 2 times 8 is 16, 4 times 4 is 16. So I see that, yes, this is an example of indirect variation. Now, to translate an expression, the way we say this is A varies inversely with B. And so we would write that as A is equal to the constant of variation divided by B. Okay. Now with direct variation, the equation for direct variation is y is equal to kx. And so that means our k value, our constant of variation, is going to be equal to y divided by x. So in the table below, if I wanted to test it, I would always do test for indirect variation first, just because it's so easy to multiply the numbers together. 1 times 3, well, that's 3. 2 times 6 is 12. Oh, okay. It can't be indirect variation because the product of x and y isn't the same for all the data points. So then I'll go and try direct variation. Okay, y divided by x. So, oh, that's not very difficult. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. So yes, this is an example of direct variation. And when we have written expressions of this, we could write W is directly proportional to V. And so we would write that as W is equal to K times V. So go ahead and work some examples on your own.